Welcome to Robots in Depth. Today I'm honored to have Daniel Pizzata from Modbots here. We're going to talk a lot about modular robotics and their great products they've got coming out. I'm so excited that we're going to see modular robotics out there in the world, but we're going to start where I usually start. How did you discover the field of robotics? How come you're now building cool modular robot systems?
Good question. So my advent into robotics actually began in the defence sector in Australia. So I grew up on the West Coast and ended up joining the defence sector in 2009, 10, thereabouts, maybe earlier. But I worked for an agency called the Defence Materiel Organisation, whose prime mandate is to equip and establish all the armaments, and that can include everything from aircraft carriers all the way down to M&Ms, for the service sector, whether you're in the maritime, aerospace or land division. So I actually worked throughout a variety of different areas inside of there until I ended up in the land division supporting a project team that wanted to have autonomous vehicles. And it was a vehicle system that needed to probe the electromagnetic spectrum of a richly configured vehicle covered and laden with antenna systems. So the point would largely be is we would buy UHF through VHF through a whole bunch of different antenna systems, and they would cause co-site interference. We had to characterize the system. And when you think about a military vehicle in the middle of the desert, it doesn't have a cell tower nearby. It is the cell tower. So you can't be close to it when it's irradiating. When that energy is coming off those antenna systems, it's dangerous. So you can't probe this with a human being. You need to have a vehicle that ideally isn't a communication sink and affects the EM spectrum, and is also able to basically be left alone for a handful of hours to take thousands of measurements, instead of getting human to do it that would cost a significant amount of money, and we would end up with maybe 10 measurements. But the complexity of the integration of the electronics and hardware, the mechanical design, the communications, the software infrastructure and architecture, and then of course meeting the deliverable requirements in time, a timely fashion under cost, all the standard project aspects, was the most rich challenge that I'd ever seen. So this was the best cross-section of the multidisciplinary nature of robotics. And I wouldn't necessarily have referred to it as robotics at that time. I just knew that I needed to create this thing that was a fundamentally decision-making, reasonably pseudo-intelligent device combined with all of the rich disciplines that I've enjoyed learning about. And from that point forward was essentially hooked. I wanted to try and find the space that would give me enough room for growth as we evolved in the technology as I could, and that was robotics.
And then you went on to do other things, or before we get to the modular robotic stuff?
So along the way in that application, we actually found that just the single axis degree, single degree of freedom solution was needed. We needed to lift a probe up and down actually in a vertical space. And we found a piece of technology that would interleave a handful of sheet metal items that provided
like
this
a SIP, basically.
Yeah, it was a strong, rigid device. It would give you nice rigidity. It could hold a probe.
SIP.
Except this thing would only go up and down and cost anywhere from $10,000 to $12,000 US. So it didn't make sense that we were going to pay a single degree of freedom for this and then integrating it with actual sensors so we could get precision feedback on its position, and then working our way back through the kinematic chain to understand where the probe was with respect to the irradiating antenna systems. It was all too complicated. But I've worked on a variety of projects from secret comms up to aircraft. Worked with Boeing aircraft within the defence sector. I've worked on naval vessels in combat system solutions and stuff like that, but I was never really a good advocate for defence, to be honest. And I was much more interested in doing something that would also provide to the community in, kind of the way that defence does, but much more in I'd like to see technologies that can be commutable and transferable and portable across a variety of disciplines. And I've loved the idea of the human-machine interface. I still love the idea of the human-machine interface, the ability to create technologies that can leverage on the disciplines of medical, biotech, robotics and automation and industrial engineering, industrial manufacturing, and all these different disciplines can now benefit from some platform centerpiece, some basis with which that knowledge can be injected and then installed elsewhere. And ideally, no matter where we put it, if we find a commercial strategy for that technology, then ideally we can start to disseminate it into each of these industries. We prove one vertical and we move to the next. And so it was very clear, like, robotics has the versatility to do that. It's just, at the moment, got complexity, and it's expensive, and it's hard, and you need a lot of time, typically, and none of these things are available to you unless you have a commercial strategy. So, so I've done a lot of things that kind of fed into this ecosystem, but the reality is, it's not just that pushes you to want to create new technology. It's also, it's a personal endeavor and a personal grinding with the ecosystem that I was in. I didn't really like being around what was ultimately the public service environment. I didn't really enjoy the, to me, not quite ambitious enough tone of the world that I was in. I wanted to do something that fundamentally pushed the limits of what I believed was possible. And my perception of what was possible was significantly greater than, apparently, than the individuals that I sat next to. So a combination of this personal push and this desire to thrive up and do something grander, and this desire to see technological challenges benefit our community across a series of disciplines that leverage each other, just meant, well, we need a platform, we need a technology that can service that. So.
And how did that lead to you then starting ModBot and getting into modular robotics?
Yeah, so it starts as a combination effort, and this is where the duality was a necessary part of the technology. I met a guy called Adam Ellison, who's my co-founder, and he is an incredible mind lent to the beautiful mechanical expression. Creating transmission ideas was something that he did as a pastime in his idle efforts when working for the automotive sector and a variety of other spaces. And in reality, the birthright of ModBot is this combined coalescing of problem spaces shared between us, as well as the personal desires to accomplish something together. And, truth be told, we started off very small. We thought, why don't we create a piece of technology that can test our capability to work together and provide a little servo actuator that would be a significant improvement upon the existing state of servo actuators. When you pull them from the hobby sector, they're typically not that high quality, they can't carry the load you want, they have irregular torque, they have cogging, they have all these other issues. And at the same time, Adam really wanted to test a handful of technologies that he was thinking, and I really wanted to expand the platform. So I wanted to enable an ecosystem that could support the community. So this combined effort meant that we kicked off this project about 2.5 years ago with a test of a hypothesis around a transmission and a encoder. And as I mentioned before, the only thing really missing from that is the ability to find a commercial strategy that gives you the time and resources to let that technology flourish. Because it's one thing to have the idea for something cool, it's another thing to have people's, let's say, patience to let you evolve it and let it flourish and let it turn into something real. And we ended up applying for the TechCrunch Battlefield event. So this was done 8 to 9 weeks out from the actual event itself, and all we had at that point in reality was a handful of ideas and some very rudimentary tests of assumptions on the technology. But, and this is then, as I say, full circle, the technology and the commercial element then came together because we then sprinted for 8 weeks to create everything that we needed as far as the vision. And alongside this technology piece came software, came the sudden apparent desire to radically simplify the interface for controlling robotic systems, for enabling you to keyframe and just move your robotic solution if it's effectively just a precision motion platform from point A to point B. So giving people an ability to not have to necessarily code, but to move virtual objects or to move the physical robot and gesture it and then keyframe it. Combine that with the scalability of this solution, adding more modules, and we've ended up with this like Lego-like module set where if we take the actuator and we combine the fundamental principles of anthropomorphism, we think about that same thing of like the human-machine interface, then we have an actuator is essentially a muscle. We have a bend that represents these joints within the musculature system of our body. And then we have these bones that represent these straight lengths. And this fundamental basis gives us the kinematics of the human body. And so what a great place to start. That's been proven through the evolutionary cycle. We see that we have evolved and we see that this seems to be working for us. And in reality, most of the systems that we interact with are designed to service this form. Okay, so bring us forward, and now we combine all of this stuff together and we go, what we really need is to design high-quality fundamental modules that represent these elements of the anthropomorphic form and present them in a package that can have a commercial viability.
By being easy to use, by being easy to reconfigure, and that's exactly why I love modular robotics. The fact that you can build whatever you need from them, and you've added then keyframing and software and controlling them easily. I know that that's something that the researchers in modular robotics is really working hard on. How do we not only make the modules but also control modular robotic systems, which is much harder than a general one, because if it's easy to build the physical hardware and very hard to program, we haven't gotten very far. It has to be easy to do all of it, right?
Yep. Yeah, as far as I'm concerned, what I wanted to see, and what we both, myself and Adam, wanted to see was we wanted to take the rich, complex building of robots out of the expensive research facilities and hand them to the millions.
Yeah.
That's kind of the core of ModBot. We want to make robots massively accessible.
Yeah.
And for us, they need to be simple, they need to be affordable, and they need to be useful. So to that end, I actually realized even recently, like a lot of the marketing stuff and jargon that we kind of start to use now is this: it's simple, affordable, and agile. And agile, to us, seems to be the best representative term for what modular provides. Modularity gives you the ability to be flexible, to shift between use cases, to make a right size fit robot, to design your robot that specifically serves the purpose of the problem space that you're actually addressing. And shift people out of the mindset of worrying about what the robot has to, like how the robot's going to work, and instead focus on the task that they want to accomplish instead. So,
very interesting.
Yeah, these are the high-level layers of thinking, I guess, that come from that.
And you've now been working on this project for, as you said, 2.5, 3 years or something.
Yeah.
Can you tell us a little bit about the journey, and then we'll talk about where the project is right now?
Yes.
Because it's been a journey, I know.
It's definitely been a journey, yeah. It's funny, I like to pre-frame the story, though, with the reality that every startup seems to have a shared story, but it's all fundamentally individual and unique. So we all have to go through it ourselves, it seems, but the parallels between them are phenomenal. But Adam and I met back at university. It was about 10, 11 years ago. And we actually parted ways and had our own history through careers and life and so on and so forth until we met again back in Melbourne. And in doing so, Adam had actually done a lot of entrepreneurial stuff. He had worked through the automotive sector and then done a bunch of startups. I had done a handful of startups of my own, but had worked through large enterprise and defence and then contracted out to BAE Systems and done a few, as I say, companies in sort of on the side. And we, as a result, we're looking at the idea of starting an entirely new concept at risk and evaluating our life and how that would look if we were to give up everything and give it a go. And TechCrunch was the thing that really pushed us over the edge, because we literally presented, we started what we thought was going to be the hardest work, sprint of our life. And we did 7 weeks of sleepless nights to create what we were hoping was going to be the first prototype that we could put on stage at the TechCrunch Battlefield event, beginning in 2014. So, and at CES, live in front of the lights. So it's a terrifying concept, but gee, it was a motivator. To the point where we were up until 1 a.m., 2 a.m. every single night for about 7 weeks to try to get this thing across the line, right up until flying over to America, not knowing what's going on, landing there the night before, having about 25 minutes of sleep. When we finally pull everything along across the line, branding and visual imagery and basic rudimentary electronics and mechanical architecture, and then presented. And 4 minutes flashed by, and then we're walking off the stage, and we're presented by a colleague actually of now who works for us, Soroya, who handed us a brochure and effectively said, you need to come visit us in San Francisco, because myself and Brady, we're part of an incubator called Highway 1. We went back to Australia after visiting them, and a week and a half, 2 weeks later, we got a call from Brady, who basically said, so we love you guys, and we need you back here in 2 months. And needless to say, Adam and I actually looked at each other when we read this email, actually, and I pretty much remember the only expression was, well, shit. What are we going to do now? So in reality, what we did was we presented a package that we couldn't say no to, and we said to them, look, if you give us this and you give us the time we need to sort of figure out how we're going to get there, then we'll do it, thinking that we were really pushing hard. And the only response we got back in the email was, sure, see you then. To which we went, oh shit.
And then now you can come and...
Now we're done, yeah.
Yeah.
They accepted what we offer, what we put forth. So a few weeks later, that was it. My friend was living in my house and I was in America. Adam had thankfully convinced his girlfriend that this was all a great idea, that we should pick up our life, and we moved over. And we landed in San Francisco, completely foreign, in a new environment, and had nowhere to live. No rental history, no credit cards, no access to a cash except through an international medium.
And the rental situation in San Francisco was better then, but still terrible.
I'll put it this way. I mean, I was living, I thought, a higher expense than I wanted to, living on a 2-story wooden floorboarded, beautiful pan-European apartment in Chapel Street in Melbourne in South Yarra. Beautiful, beautiful area. And I came to San Francisco and I lived up a ladder in a corridor about a single bed wide, about 4 single beds long, for about 9 months and paid $1,000 US a month for it in a warehouse. I'd hop over a handful of meth addicts and heroin addicts that lived in the bridge just down the way from us. It was an unusual paradigm to think that I'd come to the land of innovation, to this city of huge and immense big thinking, to have such an incredibly difficult experience living a natural and normal life. Because we were just challenged in every way. It was crazy expensive. I was confronted by the size of American meals. Couldn't escape cheese or sugar, but no, it wasn't that bad. But
I heard about bunk beds now in kind of a hostel situation costing $1,800 a month.
So I was also privy to that reality, and in fact, when I landed in America, I had applied from afar because I was concerned about having a place to stay when I got here to a communal living facility. It's a 4-story place that you pay about $1,250 US dollars a month to live in a share room in a bunk bed with about 70 other people that share one kitchen. And it was terrifying. It was a really awesome kind of collaborative community environment, but at the same time, it was a challenge.
It was easy to stay late at work when you're coming home to that.
Yeah.
So for the businesses, were probably good. Not many distractions at home.
The thing is, the reality for me was with the intense-rich amount of brain power that you consume, having to try all day, you just get tired and fatigued. So all you really want to do is just go home and switch off. You want to isolate yourself away from people and allow yourself to recharge.
Basically sleep, right?
Yep, sleep, rejuvenate, go back into isolation so that you can recharge the batteries. And you don't really get that when you share a bunk bed.
No.
So that's when I moved. And Adam lived upstairs with his partner, and I lived downstairs with this warehouse that's in an area between Cherry Hill and the Mission. And it was a really, really cool downstairs area. The guy that owned the place had turned it into his own little personal clubhouse. But at the back was this little commercial ladder that you climbed up. And yeah, it was just effectively a nook. I called it the mezzanine corridor.
It's like in the head of John Malkovich, this, right?
Oh, exactly. It was just like walking through the mini door on floor 7.5 or what it is, or 7.75 there. Yeah, it was a funny lifestyle. But the reality is, it for some reason had no bearing on what we were trying to accomplish. It was the willing sacrifice that we were making to start a brand new idea and actually stomp the pavement, and in reality gain the true credibility that is required to know what it takes to work for something and bring it to life. So we did this incubator, and we were 12 weeks into the incubator. We actually got flown over to China by Highway 1, and we were actually presented or approached by Brady and one of our other colleagues, who said, you're not going to make it to demo day. We need you to reconsider if you're going to go on stage. And we thought, what are you talking about? Of course we'll make it. And thought about it for a few more moments and went, actually, we're in robotics. We have more challenges than everyone else, presumably. Self-confessed.
You got software on top of the hardware.
Well, we have a lot of risk. That's probably more to the point. Because what we do in robotics is we stack the challenge. We have a mechanical interface where we create a new transmission solution, and we stack that with a custom motor, with a custom electronics encoder and board, with a solution that doesn't necessarily pass EMC and EMI and know if we're going to have any communication errors, and then you have to run the software. And we wanted to have a Bluetooth configurable and controllable solution from the phone that could run a mobile robot when we got on stage. So what we decided to do was we realised, well, if we do a sprint and we utilise some off-the-shelf technology, then we might be able to put ourselves in a position where in 5 weeks' time we can deliver what we need on demo day. So Adam and I came back from China and we designed and designed and we worked until 4 a.m. every single night, thinking that the last time we did the sprint was going to be the hardest time. This was going to be the hardest time. We worked every night for 5 weeks solid, and we found a prototyping shop in Shenzhen that helped make all the mechanical systems for us. Everything got delivered in 2 weeks' time. And then we sat there working every night. I was soldered up probably 300 or 400 systems of solder joins that were required for our communication to power infrastructure. We put together the board, put together the electronics infrastructure and software, put the mechanicals together, designed the bearing base and the bearing retainer, put in a system in our form factor. And then Adam sat in a dungeon room, slowly assembling every single component by hand, singularly, without an ability to test or check anything. I created all the electronics and software infrastructure without anything being tested. And then on the night of demo day, right up, we were doing our first live test at about 2 o'clock in the morning. Before we went, well, it seems to be working, not knowing which direction the robot was even going to turn in case it was going to run and smash into us instead. We didn't know. And then managed to pull across the line with an LED-ridden, we had dry ice, fog and everything on stage, and then pulled a phone out of our pocket, stood on stage and Bluetooth connected to this real robot that actually moved and worked. We had 30 minutes of sleep, and I remember getting off the stage, and both Adam and I were approached by the CTO actually of the company that runs the incubator. And he walked up and said, "Congratulations, guys. I honestly don't know how you pulled that off."
And then you said, "Thank you very much. Where's my pillow?" Right?
We fell into a coma pretty aggressively, yeah. In fact, what was funny is we had an investor from LA that had come up that day to come visit us. So, of course, we were like, well, now we have to entertain our investor. We need to show him all the good things and get him on board with stuff and get him to invest.
Yeah.
So then we had to put on the smiley face, 7 o'clock at night. I think I had a half glass of wine, and both Adam and I looked at each other and went, I don't think I can walk. Done. This robots did this to us.
Yeah, I know. I've done those all-nighters, and they're magnificent in a way because, as you say, you can get enormous things done.
Yep.
But after that, I'm getting too old for those. I'm dead for a week.
So I would
poor Adam's girlfriend.
I know, exactly. Yeah, and she's in a foreign environment. She's having to find out if she can handle the visas and deal with finding a job and find a stable environment. Of course, that's your rock. If you've got a partner there that can help you out to get through that, the startup environment like that, it's pretty troublesome because you don't know if you're going to get paid. We worked for 1.5 years and we didn't earn a single dollar. All the money that we took in investment went directly into the product and rent, and that was it. So. But yeah, honestly, that was chapter 1, and I wouldn't change a thing.
No,
chapter 1 was
this
amazing.
is also a life adventure. It's so valuable to have done that, and I've done that in previous projects, and that's the best times ever, right?
Yeah, I mean, it gives you perspective, credibility, and it actually earns a lot of respect. I think when you can show and demonstrate the sacrifice you're making for something real. Investors see that. They know that you're committed. They know that you're the right person that aligns with this product, this thing that you believe in. So that passion is a requirement, I think, of longevity, of sustainability. So.
And they also know that when that's needed, because now you've done 2 of those sprints. I presume you've done more since then. There's going to be those sprints in the future too. And there are those sprints for even large companies. I'm sure Apple sweated the first release of the iPhone the way you wouldn't believe.
Yeah.
So that also shows them that this is somebody that doesn't crack under fire, doesn't crack under pressure. So I think that's and it's also, as you say, it gives you confidence because I did that once, I did that twice, I did that 3 times. I could do that.
Well, it gives you perspective because the more you do it, the more you realize there is another end to it. So you get to the other side and there's a beautiful, there's a rich fruit orchard bearing fruit. So
Very interesting.
Yeah.
So should we discuss the product now? A bit, and then we'll go to when it's released and how people can get their hands on it.
Yeah. So that story really is chapter 1, and chapter 2 is now. We at least get to distribute our energy now across a team. So the company turned into a team of 16 people at the moment, based in San Francisco, and we've just released what we call Build 1. We're at the beta technology stage now. We've done a first release of the technology. We've moved it to build to this beta build. The technology at its core, and the bread and butter that we fundamentally offer, is a consolidated actuator. It takes a transmission and it combines it with a highly customized and focused brushless DC three-phase motor. It has the encoder technology, which is our own custom technology, integrated onto our own controller board, integrated into a orientation agnostic, centrally spun actuator. So this is a high torque density actuator, and that's its fundamental offering. But it's a sophisticated software solution that provides us with the ability to cancel out cogging, to have a nice smooth response. We can implement field weakening solutions to increase our speed range. We can have high-speed communications to the systems on the front of our connector with, at the moment, EtherCAT connection. We run a 48 volts DC bus line to it, and we can pass the parent comms straight through the system, which in itself is making a pretty incredible offering in the hardware. Because what you've now got is a high torque, continuous rotation, low inertia robot joint that can both act as a robot joint, but potentially a wheel or something else you might use for slam or ground-based movement and stuff like that. So this bread and butter building block then combines with different types of bends. We have at the moment a P bend and an L bend. The P bend provides a nice balance point in the system, so all of the weight distribution is over the baseline. It gives a really good dynamic response, but it has pinch points. So we wouldn't use this particular bend for collaborative robots. And the trend in collaborative robots is real. We know that the stepping stone to a fully autonomous factory is to have humans and robots work together much closer.
I'm definitely of that belief too.
Yeah. So the L-bend services that. And the L-bend then introduces a gap between our, let's say, bones elements of the skeleton of our robot systems, so that the fingers don't get crushed and it's intrinsically safe. If you then combine that with the software system, you have collaborative as an option. And to us, that's really, really interesting. And Adam and I often talk about that, and he's of the opinion that in a collaborative, it's a great approach, but it is a stepping stone. So we should be ready to enable a platform that can allow people to, when they want to flick the switch and just make it go fast, we can do that. When we need that throughput, we can do that. So we can provide the feedback to the customer so they know that we're in collaborative mode, but it doesn't always have to be there. So, and that's pretty cool.
Yeah, I also think that that's absolutely what we're going to do with collaborative robotics, but also the duality mode there, with collaborative and non-collaborative. So you can do part of a task together, and then the robot could quickly provide automation, and then we could again do things together. Yeah,
and this leads actually to, I mean, the other aspects of collaborative are, you want to work alongside the human. But again, if you use that anthropomorphized mechanism, the humans more often than not don't run into each other. So I usually don't have to run into you to know that you're there. And that's because of my rich sensing systems, and of course, and the mental history that I keep as a track record of where things are in my environment. And we want to introduce that into the platform as we move forward. So collaborative robots right now have kind of gotten to the point where we either introduce mechanical compliance, like the Rethink Robotics solutions, that we can then have torque sensing and detect when we've impacted on things. Universal Robot uses like load sensors, and they can have current sensing and these kinds of things that can detect the delta and some basic external torque sensing. But ideally, it would be great if you don't have to hit anyone to know that they're there. So capacity.
Eventually, that's what we have to do. Right?
Yeah. So vision systems, capacitive systems, ultrasonic systems, these will all be part of the ModBot platform as we move forward, different modules that you snap into the system that start building the picture of the world around you. And this, to me, is the key to the future of where robotics will start to evolve. Right now, we are dramatically improving the intrinsic problem, which is the robot itself. We take the complexity away from the user now because we solve the coupling of bearing and transmission and motor and control electronics. We remove all the interfaces, which means we reduce the mass of the system. We increase the strength and rigidity of the system because we have the beautiful, what we call common mechanical coupling. We can maintain stiffness throughout our system, but also provide modularity. But in the future, we need to start dealing with the extrinsic problem, which is the world around us, the dynamic, changing momentum, the organic sea of stuff that's going on in our environment. And that will be this perception system plus machine learning, plus other systems that then start to tell the robot what's going on around it. And so that's going to be part of the vision as we move forward. And here's how I think that can occur. And Adam's actually created an analogy about this in the past. We did a presentation that was put together down in Carlsbad a while back. So I defer to his analogy for this one because it's a good one. Think of the PC revolution. There was a time when the mainframe existed in its first creation, and it was a large, single-purpose, very expensive piece of plant and capital that was only really accessible to a variety of people in a server room somewhere. That was computers. Somewhere down the line, we found a way to introduce it to many, many more people. It became accessible. And the way that it did that is because we actually broke the individual constituents of that solution into modules. We created desktop PCs that had motherboards. Monitors were separated. We had graphics cards and floppy drives. We had each of the individual components serviced by someone that was best to do that part, and then coming together. But the modules meant that we could now make the computer that you need. It was specific to your purposes, either by cost or by performance, but either way you could find the little slider line or slider bar for exactly what you needed. And these individual modular constituents allow you to have this flexible response to your computing needs. And now look at what's happened as a feature of that. We introduced accessibility, which radically increased the technology. It went up. We had more and more solutions being solved. We had more people thinking about computing solutions. And it's then evolved into smartphones. And what we actually started to do again is now we go through this modular phase, we actually have a consolidation phase again. And this consolidation phase starts to look like individual, special purpose, but very, very capable solutions that have earned the benefit of, or leveraged on the benefit of this modular phase that gave all of the learnings and all this experience to that technology. And now we have smartwatches, and we have this further, like wearables and gadgets and these kinds of things have trended, and that's really like leveraging on that stepping stone aspect. Robotics is largely in the mainframe era. Right now we have large, expensive, single-purpose capital equipment that when it's not being used, it just sits there ultimately wasting footprint. And they're beautiful and amazing machines, but they're not necessarily flexible, and they don't allow more minds to be using them to solve more problems. So what we need to do is enable robots to go through this expansion phase, give it to everyone, give them the flexibility to start solving problems, and we may even find that I think there'll always be a little bit of a place for modular, but even the ModBot system will start to provide solutions that make sense for our future as well. And we start adapting towards deep learning solutions and algorithms. We introduce data plays. We provide IoT connectivity that enables you to get sensor feedback on the robot that's sitting on the factory floor because server number 4 has got a temperature fault. So we report that up to the server, and we automatically send out a new server.
And even our integrated devices like smartwatches or laptops or cell phones are modular under the hood. I mean, hard drives in any laptop, they're all looking the same, right?
Yep.
And CPUs all look the same, and all the Bluetooth chip, they're all the same. It's just the packaging that are unique to you and me, right?
Yeah, and that's then the difference about what is the fundamental building platform versus what the user sees, what the customer sees. And if you can actually enable the flexible background to start creating awesome solutions that solves a problem, then the factory floor in China that makes smartphones can use the modular platform for their purpose. But then the giant Siemens facility that has to create large, heavy plant equipment like large electromagnetic systems or motors and status systems. Status for motors, for example, can use the same tool. But to them and from their interface, it looks exactly like what they need. So.
Yeah, amazing. And we see also the crossover between different areas where one area pushes for a development and then another area benefits from it, but that area in itself wouldn't have created it. We see this with the GPU. The need for people to game, or the desire for people to game, created these enormously powerful GPU systems. And suddenly you can do so many other things with them, video editing, or you can do a supercomputer on a regular hard drive, regular desktop machine just because we can lever this GPU. So we're going to have these crossovers in robotics too. Somewhere somebody has a strong need for something. And then that becomes available for everyone rather than staying in that domain, which is what I've done if we had a mainframe still where everything is locked in and proprietary.
Yep. Well, it's actually an interesting point that you then bring up, because to me that is then the next evolutionary vision of where this stuff goes. Because the GPU is an incredibly rich, now sophisticated, it's learnt from the benefits of this modular tone and it's been specialized piece of hardware. But where has computing gone? Computing has gone into the cloud. And now we actually have a distributed model of processing and computation. We no longer have to necessarily associate this mechanical system to its processing and its software. They don't have to be co-located, they can be distributed. So there's no reason why we can't automatically respond to weather patterns or to some system of affairs or like a volcano eruption that occurs in some place on the planet that automatically gets detected by a deep learning algorithm on the internet that then ramps up an automated factory in China for the distribution of emergency aid services. And then they automatically go into a supply chain and logistics company that then drones them to wherever they need to be. So then a robot in itself, including the ModBot system, could mean you build a modular robot that's sitting on a factory floor in China, but you've got a software technician sitting in San Francisco who writes the application code and deploys it over there. And when he's ready, that maintenance data can then be sent to a service technician that actually monitors all of these systems and, as I say, sends out automatic deployment of each of the modules that need to be repaired to any robot elsewhere. And then if you get stuck, you're on the factory floor, you call up Modbot, and Modbot can just go, well, why don't we just remote into that robot and we can help you to build that application. Now think about this even more. Every time you train that robot, you may well be in a position to actually capture the data with which you're training that robot with. And there's no reason why you can't use that data to then automate how you train the next robot, because it's learned how you trained it.
It's only the difference between what you taught the last robot and what you taught the new robot that you actually have to teach them. With the human, you can just inherit that.
Yeah.
Which is what we do in source code or in software all the time, of course.
But it's not so much just let's say, a replication of software, like I've created that solution and I'm going to copy that software onto that robot, but rather I'm actually going to copy the way I trained that robot to something else. You actually step a layer above and you go, well, now I can improve or automate the way that I train the robot. So for example, if I tell that robot, okay, well, I need you to drill a hole, it's going to go, oh, I've already been taught how to do that. And then when I tell it, look, this is what you need to do, it'll go, oh, no, I already know how to do it better than that because I've been taught 15 times before. And the last time I was taught how to do this was, in Germany, and that person told me that it should have been done like this. I now know how to detect and nudge around a hole, and I can automatically do a helical spiral and find myself and deposit it down.
Yeah, and of course also we'll all be using state-of-the-art skills, because say that you want to teach your robot to do something, you can find a person who's the best at that thing and have him teach the robot to do it. So we're all going to be running like Usain Bolt because he taught the robot to run, right?
Yeah, exactly.
And we can all develop and become the Usain Bolt of a certain set of things. We don't have to spread ourselves thin by knowing everything. We can be focusing on what we are good at and what is the core of our business and our needs, right?
Yeah, that's probably what it comes down to at core. At the end of the day, I think we are such a globalized and diverse community now around the world, and tech is very well heavily connected. I mean, there's definitely lots of worlds that aren't still in the world connected up the way that we know we can in the high-tech world, but do what we know how to do best. And let's leave the rest to someone else. But more importantly, let's give them the tool that enables them to do that. And I think robotics has been something that's been, as I've said before, stuck in the really expensive research facility. Now, if we can suddenly give a lower cost, simpler technology to many, many more people, what we actually do is enable an entirely new class of roboticists. We now have different types of people coming up with the solutions in new ways and new perspectives for new challenges and new problems that we haven't thought about before. So that's kind of why we went for this. We believe that the platform is a necessary stepping stone to help people to do that. But one thing I'll add into the platform part of the conversation that I think is important is I don't believe any platform is truly succeeding nowadays unless it is open, unless it is accepting of the fact that it does not exist purely to keep you on the platform. So the goal really needs to be that you provide a tool base, a certain sort of the platform layer in such a way that it is accessible to you as a user and that it is accessible to every other product that user might want to interface with.
Absolutely. I'm definitely with that being open, and that's coming from somebody that grew up with Microsoft and Apple, and I just hate the closeness of these systems, and being open is just essential.
I mean, open has this twofold effect. it provides a much, much greater reach of accessibility, to be honest, because now we don't have to solve all of those individual problems, as you say before. We let the people best to do that, like gripper manufacturers or perception system makers or different deep learning online cloud-based system providers, all this kind of stuff. And we focus on what we're very good at and provide the interfaces that then leverage the benefits of each of those technologies within our platform. But furthermore, because it's open, you don't necessarily have to use our platform. You can still use our hardware, but run it with your own controllers, or you could use that controller, but without use our software, but on other people's hardware. So it incentivizes us as a company to have to keep innovating. So what we're going to do is be motivated to prove to you that we keep making cool things and that it's worth you being invested in our platform, because our platform gets better, makes your stuff cooler, and we'll never lock you in, and we have the open-armed personality and culture of a company that makes it look like, hey, this is a great place.
Yeah, that also prevents you from becoming complacent.
Yes, exactly.
And that's probably the worst thing that can happen to a company. If you know that pressure is there all the time, you respond to that. And if that pressure wasn't there, you run the risk of becoming complacent and saying, well, they have to use my system, I've locked them in. And the user always wants to be free in the end, right? I mean, they're always going to break out and do something different in the end anyway. So why try to lock somebody in when you really can't? And why give that bad will, get that bad will of trying to lock people in? It's just a disaster, right?
Yeah, it's human behavior, I guess, at the end of the day. And like, if I speak for myself as an individual, I know that if I'm given more option and openness, I'm more comfortable, and I'm actually more willing to hang around. So I mean, if you don't listen to ourselves,
I'll stay voluntarily much longer than you'll stay if you try to force me, right?
And to some extent, I always enjoy, like Google. I remember when they provided their data liberation service, and it was a project and a tool that was about like, we just want to make sure that we can do whatever you want. Like, if you want to leave, here's how.
I used that just for backups, and I think it was great. And knowing that that's there made me feel better about staying. Knowing that there's a door where I can leave anytime I want to makes me stay.
It means that we're still willing to let you be in control of your fate and your situation. So we have to make robots a bit like that. And with robots is a funny term and concept in general, because what is a robot? To me, it's something that I think is going to always be an evolving concept, an evolving term. But we are heavily persuaded by Hollywood. So like what we see in movies and cartoons and the characters and the authors' creations and depictions of them seem to always have this anthropomorphized version. So for some reason, I think humanoid robots are going to exist someday, even though it's quite debatable that there's no real economic viability or feasibility for them to exist on a factory floor, because they don't necessarily operate better when they're anthropomorphized. They're better off having wheels, to be honest, or something like that. But we seem to want them to exist, so they will.
Well, I think that's also, I mean, human beings are obsessed with human beings. Monkey want to see what monkey do, right? I mean, we love to see the human form because our brain is predestined to look for faces, look for the human form, because humans have been such an enormous part of our history. So I think that probably has more to do with that with anything else.
Yeah, that's a good point. I would agree.
And it's also a very well-known form. If you make a robot looking like a human, you kind of know what that robot should be capable of. It will take a very long time before it's capable of that. I mean, before you have a gymnastic robot that can beat gymnastic in the Olympics, that's going to take millennia, if not decades, if not millennia, right? So, but we still think it does. If you see a robot that looks reasonably like a human being, you presume that it's going to have the capabilities of a human being, and even if it's nowhere close, right? Yeah,
which is funny because it's, and this is the uncanny valley argument. If you get too close and you're not quite there, it's not going to look so good. So you're almost. I remember reading an article about Pixar, and they actually found that when they created their animations, to make them too real didn't serve us any benefit, so they actually purposely make them animated, make them cartoon, make them naturally non-threatening.
Yeah, the uncanny valley is a big thing, and I am of the persuasion that I have the idea that we're so good at seeing these small abnormalities that it's going to be next to impossible to create a robot that could physically fool another human being in a room, sitting, watching them, saying, is this a robot or is this a human being? I think we're so tuned to the smallest detail, probably from the dark. This probably comes from the fact that historically we probably ostracized the people that were sick.
Yeah.
Because we didn't have modern medicine. So when somebody started behaving oddly, we shunned them out of the group.
We avoid, because I guess that's the safest way to stay safe.
Yeah, so. It's like when dogs do this, they never show you they're in pain until they're in very severe pain, because they would be shut out of the pack.
But see, I can combine two of your concepts here, or they combine in my head, where I think you talk about when people are sick, we tend to shy away from them.
Mm-hmm. Or historically we did.
But we're also obsessed with humans. So what I find interesting is when you see a maimed dog, or you see let's say a cute little puppy that has had a sewn up eye and it's had this disastrous thing occur in its life at some point, for some reason we find them cuter. We find the poor little guy just needs to be helped. Yeah, so when they
like the scar on the face of Harrison Ford.
Yes, but so those kind of blemishes and imperfections, they give us reality. But when we see things that are a little bit unsettling in the human form, it bothers us. So I think when we see someone, for example, that has a dismemberment, that concerns us. So a humanoid that has a dismemberment as well, for some reason, also bothers us. If we see a T-1000 standing there, but it's just missing this much of its arm, we don't like the visual image of it. But if I saw a three-legged dog, I don't feel the same sense of offence at all, which I shouldn't really feel anyway for humans.
Wonder if we are projecting the pain of losing our own arm on. We're seeing that this T-1000 is losing an arm. Ooh, I don't want to lose my arm, because that would be terribly painful, right?
Yeah, perhaps.
Robotics is teaching us so much about ourselves and so much about other areas that it's just amazing.
But to me, this is the reason why what I anticipate is the future of the, let's say, robot personality is likely to not be so much the humanoid as much as is the anthropomorphization of certain characters inside of these robots.
It'll be like Disney doing a robot, doing an animation that's actually quite far from perfect, because that's the optimum.
Because we accept it much more and we enjoy it. Now, there's a Guy Hoffman did a TED Talk actually about this, and he's an Israeli roboticist and actor and musician. Very creative guy, very smart guy. He worked with Cynthia Brazil, who's come out with Jibo. And they're in a space of social robotics, dealing with the human interface through the personality of a robot. And the most interesting thing I saw in his writings and his presentation was he did a study where he took two robots. One that he considered to be, let's say, the very strict and very decision-making robot, and then the other robot was one that had a personality and had a little bit of fault in its programming. So it might make a couple of errors, or it would take a little while for it to correct a few things, but it had a personality. And what he observed was, at the end of the experiment, the two teams that were given each robot gave feedback on their robot. And for the dumb robot, let's say, or the very strict and, this is matter of fact, it's a highly precise robot, they referred to it as a tool, and the unit was actually considered to basically be just like, it was kind of like a unqualified intern. It was hard to program. It wasn't so easy to get it to do the thing you needed to do. But when it did it was fine, and nothing else to comment. But for the one that had the personality, that actually had a certain amount of error in its system, they would refer to it as a he or a she instead of an it, and they actually said goodbye to it. And when it failed, there was obviously this persona, or this air of, we need to help it. Like, we need to train it, we need to help it more. Like, it's like a kid. It just doesn't know what it's doing, poor guy. So I see a big amount of room in the future as well for, let's say, social layer to exist in even the ModBot platform, where the systems of robots that you build interact with you properly the way that you interact with humans. Because again, we want to shift the problem space away from the machine and more to the task that you're wanting to accomplish. And what we want to do is do that through the rehearsed and standardized interfaces of the human body, this human-machine interface that we use to each other. The human-to-human interface is gestures, it's visual, it's eyes, it's mouth, it's hearing, it's all the senses of the body. So ideally we do that.
Thank you very much for taking the time to do an interview.
Thank you.
This episode is sponsored by Aptomica. Everything you need in modular robotics. Or robots up close, what's going on in robotics, online and on the road. If you like this interview, Don't forget to subscribe, follow us on Twitter, and subscribe to our email newsletter on robotsinDepth.com. You can also support the show on Patreon. I would like to thank the organizers of RoboBusiness US for their help when I recorded this interview.